Hey, good afternoon. This is the Center for Automotive Research Additive Manufacturing webinar. I see there are people joining in, so we will start soon. Thank you for joining. So just give us a few minutes, please. Thanks. Okay, so hello everyone. My name is Shashank Modi. I am a research engineer at CAR, and I am the host and moderator for this webinar. This is the CAR Additive Manufacturing for Rapid Response webinar. We have great speakers today who will be talking about how additive manufacturing is helping in the COVID-19 response. Where do we see additive manufacturing in the future? And what are the advantages? Where do we see applications for automotive? So I want to give you a very brief introduction of CAR. Most of you are familiar. CAR is an independent, not-for-profit think tank. We are based in Ann Arbor, Michigan, and our aim, our mission is to promote an independent research and analysis and advise stakeholders and policymakers on issues facing the automotive industry. You can see we have a lot of affiliate companies. Most of the big automotive companies are CAR affiliates. They all contribute to CAR, and we use that fund to do our research. This webinar will be recorded, and we will make the recording available on our website. And you can note down the link. It's cargroup.org/webinars. And we have done other webinars in the past. You can always go there and revisit the webinars if you would like to listen on other topics. And since we are a not-for-profit and we are doing this research on funding that is provided by people like you who are participating, who get value from our webinars, we have a donate button on our website. So if you would like to contribute to our research, please follow that link. I also want to tell you that we have our annual management briefing seminars. This year, it will happen virtually. We have been doing this webinar since last 50 years, and I believe this is the first time we will have to do it virtually. But that doesn't mean it won't be a great event. It has been an industry leader since a long time, and we have a great list of speakers, really good sessions. So you can go to our website, learn more about that, and register. It will be in August. So coming back to our panelists today, we have three great speakers. We have John Wilczynski from America Makes. He is the executive director there. We have Mr. John Walker from EOS. He's a business development manager. And we have Dan Reich from Formlabs. He is also a business development manager, global business development manager at Formlabs. So I would, before starting, let's do a round of introductions. I will let each speaker introduce themselves, and then I will hand it over to Mr. John Wilczynski for his presentation.
Sure, I'll go first. Good afternoon, everyone. John Wilczynski here from America Makes and CDMM. Very excited to talk to all of you. I'm going to talk a little bit about what we're up to as it relates to COVID and the response, and give you a bit of an overview. I've been the executive director for, I guess, going on a year. In 11 days, it'll be a year. Prior to that, I was the technology director for, I guess, about 5 years or so at the Institute. So I've been around, pretty familiar with what we've been up to, and interested in sharing that with you guys all today.
Thanks, John. Dan?
Sure, thanks, Shashank. So I'm also really grateful to be here today. I've been with Formlabs now for about a year and a half. And I should mention that business development at Formlabs is a technical function, not a sales function. So we are the part of Formlabs that partners with companies to really push the boundaries of what's possible with additive manufacturing. So getting additive into production contexts, developing new materials, new applications, larger scale facilities. And for us, this crisis has really been a wake-up call for how much we can do, both to help our existing customers and also to help society at large. And I'm very excited to tell that story today.
Thank you. Thank you for joining. John Walker? John, you're muted. Wait. Okay.
Thanks. Sorry, I thought that was on my end. So yeah, very happy to be here and look forward to presenting today. It'll be a little bit different for me. Most of my topics are medical, and I borrowed that from my counterpart, Laura. So hopefully I do the deck justice. I've been with EOS for over 4 years now, and before that had over 10 years experience around CNC equipment. So know the manufacturing side of the industry very well and where the AM industry is going. And like Dan mentioned, business development at EOS, a little bit different, actually resides within the strategy department, but it's not a separate sales function. We have a whole sales team locally in Michigan that actually works with automotive companies commercially, and I'll try and do a good job today as well to try and tie some of the medical related content back to the automotive industry.
Thank you. Okay, so before we start, I want to say that let's keep this interactive. There are a lot of options to interact with the speakers. We have a Q&A box. You can type in your questions, and I will see them. And when we have the Q&A, I will get to those questions. There's also a chat box, and if you would like to have audio, there's an option to raise hands, and I can unmute you, and you'll be able to speak. So the format of this webinar is every speaker will have 20 minutes, but you can keep your questions coming in, and then at the end we will have around 30 minutes of Q&A. So we have enough time to get to most of the questions, so please keep it interactive. So with that, I will make America Makes as the presenter. There you go.
All right, hopefully my screen is now present.
Yep, you can see it.
Fantastic. Well, thanks again, Shashank. Really appreciate this opportunity. We're going to talk a little bit about what we're doing at the Institute, and then talk through our COVID response at the same time, and try to, draw the parallels between those two activities, and then really interested in the questions on the back end of this. So I have a bit of introductory matter, since there's a fair number of folks on the call who may not be extremely familiar with what we're working on at America Makes. But America Makes is really focused on 3 major activities. It is technology development. How do we then transition that technology that we're developing? And then how are we making sure that the education and workforce community at all levels is spun up in a manner that can take advantage of this new great technology that's being developed and deployed. And we've done that. We've been working on that for years now. I'll give you a little bit more background as we go through this. But we've executed a large portfolio of projects, and again, trying to make sure that we're keeping in mind while we're doing that these key elements of transition and training, because without it, tech development for the sake of doing it doesn't really get us anywhere. And I know that is all critical to, the audience on the phone here, whether it's, not necessarily COVID related, but from an automotive manufacturing point of view, if it's not going to do something for me and I can't take advantage of it in the near term, it doesn't necessarily matter. I came from this community. I spent most of my, all of my early career in a variety of roles in the automotive sector at GM and a tier 1 supplier before that. So very familiar with the day in and day out activities at a parts producer and a manufacturer. So at the Institute, we are what is considered a public-private partnership. Many of the folks that were on that logo chart that you showed at the beginning, Shashank, are members of America Makes as well. We're a organization that is trying to connect the community. So I didn't mention it, but on the first slide, we really think of ourselves as a convener, a coordinator, and a catalyst. And I'll talk, throughout the course of the next 17 or so minutes about how we're trying to do that and what that's meant in the very recent, past 2 months as it relates to COVID. Now, we were initially set up, again, we're run by a nonprofit called the National Center for Defense, Manufacturing and Machining. It has been around for almost 20 years now, doing a very similar mission to what America Makes does. NCDMM does it across all of advanced manufacturing, whereas America Makes is really focused on the additive piece. And how do we do that? It's through collaboration. It's through our member network, through our government partners, academic partners, et cetera. We've got, well over 200 members who work on this mission with us. We are located in Youngstown, Ohio. We're one of 14 and soon to be 16 manufacturing USA institutes. So there's a network, and hopefully most folks on the phone are familiar with this. I know, many of the organizations that we work with obviously are, and then, these other institutes have penetration across other technology topics. Each one of these is set up to really focus on an area of advanced manufacturing technology. And we're the first and what we like to consider the flagship institute, having been established in 2012. We're in our 8th year, or I guess going into our 8th year of activity in executing against that mission. And now, one of the big things that we have focused on from the beginning is been making sure that we're listening to our community, making sure what we're focused on is what the interests of our stakeholders are. And, thinking again back to that convening and coordinating, it's really about bringing the community together to talk through and understand, and then build a plan on how do we execute, how do we put something in place that we're better positioned as we move forward. In talking to our stakeholders, we regularly pulse them, whether it's from a technology point of view, whether it's from a community building point of view, what are the areas that and reasons that they engage with the Institute and why they work with us. We have a very large portfolio of R&D projects. Be happy to talk to anyone about that, at some other time. But we've, got a couple $100 million of additive specific work that's gone on or is going on right now at the Institute. So we, being a collaborative partner, really look to get that information shared, get it in the hands of the community so that we're able to best take advantage of that, while making sure that we're understanding. And we have, a couple of great speakers here with us that represent the OEM side of things that are constantly pushing the limit of what additive is doing today, looking forward to what can it be doing for me tomorrow, and making sure that we're getting our membership access to this information and sharing that the best that we can. So, this is kind of transitioning now to what does this all mean? How does this fit into a response or a rapid response? So one of the things, and we've been fully engaged in COVID response for, 2+ months now. I've joked with our core team that I think this is week 10 of what has been, the multiple times per day meetings with Tiger teams and all those kinds of fun things. But very early on, we got involved because we have a lot of connections, and through that membership community, we understand who's doing what, or at least who wanted to do what and get engaged in some way. So we're very connected to the small and medium-sized manufacturing community, have worked on some different regionalization strategies. We're very interested in how the additive manufacturing ecosystem fits into the larger industrial base. So where do those manufacturing communities bridge together, and how could they be more effectively working together? So as we first started talking through what should we do, as an institute, it's great where we certainly know our share of additive manufacturing and had some ideas on how it could help. Weren't completely clear on what our role was until we started to reach out and talk to our member community, and call after call, it was manufacturers who were either stepping up or trying to step up in some way, but in most cases they didn't understand what the next right thing to do was. And so we collected a lot of that information, and we decided that it wasn't acceptable to not understand where to go and what to do next in regards to this very specific crisis. And we put together a document, submitted it to FDA one weekend back in March, and called out very clear and distinct problems that we had heard from our member community. So again, this is the kind of convening function of what we do, and put it in front of them. And it was immediately met with a response from the FDA. The next day we were teamed up. Part of what we had proposed was a community of bringing a interagency group together, and us as a public-private partner to bridge to the community on the industry side. We need to get focused. We need to understand what regulatory guidelines were, how to play in this space. There's some folks who, even those on the phone, that understand that a lot better than others, but everyone wanted to help. So that led to something that we call the Advanced Manufacturing Crisis Production Response, or AMCPR, and we built a system of bringing the community together. So whether you're a manufacturer, a designer, or someone who needs a product, you needed an outlet and a place to go. And really the power behind this was bringing that interagency group together. And I won't pretend it was all us by any means, but we were able to help, and we've been working since that day in and day out with that community to make sure that we're driving against one central mission. And in this case, that central mission was the delivery of safe and effective products. We were wanting to make sure that we were bringing folks together around designs that had been reviewed. So again, a lot of enthusiasm doesn't necessarily, that can be good and it can be bad. If we have people rushing out to and end up doing the wrong things, or worst off, ultimately harming somebody, nobody wants to do that. But with the lack of information that was out there, I won't suggest people were harming somebody, but there was the potential with lack of clarity in who should be working on what. We put together this AMCPR portal, and then that has been connected directly to the NIH 3D print exchange. We had worked with them over the years. We built a portal like that exchange for the DoD to be internally used by the Department of Defense. So our response has been centrally focused on building this portal, connecting with this interagency group, and trying ultimately to demystify, or we've come up with all kinds of cute names for the different tools that we've come up with, like Dakota Ring and Rosetta Stone and those kinds of things. But we've put teams of people in place to help the general manufacturing community better understand what they should be working on and where they fit in, and truly to understand what those rules of engagement are, and appropriate barriers to entry and how to overcome those. So this slide, if you've been on any of these COVID talks with any of these agencies, you might have seen this. We implemented this, a couple weeks into our relationship, and it really shows where NIH is the trusted repository of data, and we found tremendous value in that. And in particular, it doesn't matter whether someone comes to us, comes to the Institute to match with a point of care facility in a manufacturing community. It's important that people are using these trusted designs. That's all that really matters at the end of the day. And we've seen countless cases of where that has worked. And how do we get to the point where they're trusted? It goes through a preliminary evaluation with the VA. This is certainly not the only path, but it is a path that has proven to be quite valuable. They've tested literally hundreds of designs at this point. Dozens have actually made it to the point where they're, either the category of community use or approved for clinical use. And then the FDA has been involved, again, from day one in helping with guidance, clarification, just, general communication with us. And it's really worked out well. One of the things that's led to is very recently a document called the Regulatory and Performance Considerations came out. The product types that are listed here are the 5 most commonly printed, just general categories, if you will. And this document runs off the page quite a bit, but just for the sake of example, it shows as a manufacturer, I can look at this and understand, do I meet these, can I check these boxes off? Do I meet these requirements? Am I labeling things properly? Am I packaging them properly? Do I have good manufacturing practice in place? And again, this list goes on. There's a series of questions or check boxes around material considerations and those kind of things based on the product type that you're trying to deliver. Again, this is all fundamentally about people having the information that they need in order to deliver the service that they're looking for. And how this relates back to the grander America Makes National Institute mission is we've always, and for years, have been talking about distributed manufacturing and what does that mean and how do we do it. And additive truly is a technology that can demonstrate its, the potential of distributed or swarm manufacturing. And we all feel that, that is an opportunity. COVID has really provided us the platform, although we didn't want to, but it's truly stepped up. And we've been on a number of panels here recently talking through, and hopefully many of the folks on the call are familiar with additive, but if you're not, additive has truly, and more so than other technologies, especially emerging technologies, proven to be a vital capability or a vital tool in distributed manufacturing and our ability to actually meet that desired end state. So COVID has been a very regional fight. We know that from region to region, the needs are different. Therefore, the response from the community has to be different. Additive and really the ability to utilize a trusted digital model has proven to be extremely successful. We need to make sure that we amplify that. So we as a grander community or kind of the AM community at large are taking that message forward and people are hearing it. We need to make sure that we're continuing to get investment and more reoccurring investment. We build a, much more bold, I'll say, national strategy around where are we at and where do we need to go. We've learned a lot through this response, and I think in particular, we've identified that we're not ready for these kind of things to happen, but we know now, at least in some cases, how to better prepare, and specifically around having a digital repository of information that can be critical, and that has very clear transition paths to supply chains. So being able to distribute and produce an automobile in anywhere in the world, we need to be able to take advantage of supply chains across the world. We all understand, automotive is a very global economy, or a global supply chain, but we need to be able to reach out and get access to those manufacturers wherever we need them and get them set up and established, and have the workforce that is able to, again, take advantage of those new technologies. So another piece that we've seen, and we're, I would say see unraveling before us, is we had a number of manufacturers, I'll say more conventional manufacturers, who were looking to not pivot their business, but respond in some way, and Additive was and has proven to be an opportunity to do that. But maybe they didn't have the workforce that was skilled and capable to take advantage of this technology. So we, and I won't dig too deep here, but we've been working for years on what are the requirements that a job classification should have by a variety of levels, whether it's automobile, the automotive, aerospace, energy, all these sectors have a need for a skilled and trained workforce. We need to make sure that we're getting those systems and those credentials and things established, so that when we need to, whether it's pivot production or respond, in this case, to a specific crisis, we need to make sure we're well positioned to do that. So that's a little bit. I have some backup slides here. I know they're going to make the slides available. I have some more, much more specific project examples that aren't COVID related, but instead are where is additive manufacturing making an impact today. So there's some, for your reading pleasure later, some quick one-pagers on material study that was done and now is a qualified material for aerospace, an investment casting story, part distortion story, and then one on a particular a powder bed story. So if those are interesting, please take a look. If you have any questions, certainly we look forward to the Q&A later on today to talk through what we're up to.
Thanks, John. Really informative presentation. I have a question before we move on. When was that light bulb? Where did you get the first call and you realized that, hey, additive can be really big for this response?
So where we're at in Ohio, everything shut down on March 13th. It was a Friday. That transitioned to, Monday, I guess, the 16th, setting up offices and at home and thinking through what this new normal was going to be. And even at that point, weren't really clear. We were more focused on how do we, set up events and what do virtual events look like. And, the whole event, conference season was about to hit, and most of those were going to be canceled. So we were working on that. That led to a couple of conversations that then very quickly led to us reaching out to a couple of the standards bodies that we work pretty closely with and a couple of the large manufacturers. And it was this overwhelming response that people wanted to help. And at the same time, there were some designs, I'll just say, were floating around on the internet that weren't really proven at any level, and we're getting a tremendous amount of traction. And we had talked to some folks, and they had some major concerns with those designs. We'll just say, we'll leave it at that. And that led us to, stepping back a little bit and thinking, and then that was an assignment to a handful of our team members and said, go reach out to these different groups. We got feedback immediately within, I think it was Wednesday and Thursday of that week, and we knew we needed to do something. At that same point is when we realized we have no idea what the regulatory landscape looks like. I mean, this, you know, we're not experts in this space, but we certainly know the additive community. So we've got to help coordinate the activity. We don't know what to trust. So I don't think just Googling and seeing what pops up is a great idea, especially if you're delivering that someone on the front lines.
Yeah, I want to tell to the attendees that please go and look at the design repository that John was talking about. I looked at some of the designs. It's a really cool website, and you will learn a lot. And if you have a printer at home, you can even download and print them.
So there's hundreds of designs out there now. You know, we've now learned that it's more about focusing the design community. You know, we don't need 100 versions of something that's already been proven. We need to have them focused on the next right thing. And that's what we just always tried to keep in front of us. So it was really because people wanted to be so engaged that we got involved. And then we just started, you know, banging on doors, especially in our on the government side, to make sure we understood how to help. And that immediately led to a response. And then that next Monday, after I sent a letter to the FDA commissioner, we had a call set up with the VA, FDA, and NIH, which ultimately led a week or so later to an MOU that they all signed collectively to work together. So it all happened extremely quickly, but it was because of folks. And, you know, two of the companies that have been very engaged are about to tell you about what they did to actually, you know, make an impact. So it was
okay. Thanks for bringing people together. And at this speed, it's really mind blowing. Okay, so moving on. Our next panelist is Mr. John Walker from EOS. John, I'm going to make you the presenter.
Okay, great.
And all yours.
Great. Does it still, real quick, just technically, does it show the whole presentation or presenter mode when I use this format?
It shows the PowerPoint application. Like,
all right.
Yeah.
Perfect. Great. So again, thanks for having me, and actually a really good follow-up to some of the information that John was presenting at the end about the NIH repository and also
John,
understanding
I'm
regulatory hurdles.
It's actually, you're not in the presentation mode.
Yeah, correct. You just see like a title slide, right?
No, I mean, I see the list of slides, but you're not in the presentation mode.
Sorry about that. Hang on one second.
Yeah, because I think you have to press, yes, now it's good, but I see half the screen now.
Is that better?
You're good. Yep, you're good.
Okay. Great. So again, good tie-in with John, and also, as I mentioned, I have a counterpart, Laura at EOS, who does business development for the medical space, and she's actually an FDA alum. So we have a really good handle, I think, on some of the regulatory issues, which we will touch on. And one of the things, if you notice, as I was prepping and working with Laura yesterday to tailor her deck to an automotive audience, is that title slide is March 20th. And I think it's kind of interesting just because it's been almost exactly 60 days basically since this affected most of us. And even as rapid as this has changed, some of the information that we were looking at yesterday is almost outdated because a lot of the projects that we were working on 60 days ago are either finished, stopped, or have evolved. So it's kind of interesting to think about with just how dynamic this situation has been. And if we take a look at the format of today's presentation, what we'd like to do is share what are some of the unique challenges of COVID-19 that it's been faced to the additive industry, and then how we can continue to think about using those things long-term to better all of our organizations. And I'll also try and specifically as well tie that to the automotive industry, being that, you know, medical is such a different thing. So one of the first situations that we've tried to face is the PPE mask shortage. I think that's probably one of the topics that is on the forefront of most people's minds. And like John alluded to a little bit, there's, you know, if anybody spends any time on LinkedIn, There were tons of people sharing designs. The local news was covering hobbyists and everybody trying to help out, which that collective good is awesome. But the part of that wasn't covered as much is that when things are not approved and not vetted, it's really unclear what the safety aspect is. Could somebody be putting a device out there that actually doesn't function correctly and therefore puts somebody in harm's way? So that's why I think it's really important for organizations to get involved that would also look at the regulatory side of things and do it correctly. So if we take a look at what COVID's solving today is to quickly bring new designs to people very quickly, and also figure out what these design guidelines could be so that they could be distributed to different people and scaled very quickly. And specifically to COVID, the way we were trying to apply this was looking at things like masks. You know, some of the challenges that we are facing is there's a mask shortage, and we're literally throwing away masks daily because they're not reusable. And when the masks are the traditional paper surgical masks or like the 3M mask pictured on the top left side of my screen, that mask isn't perfectly form-fitting to the person using it. So there could be gaps in coverage that could potentially be weak points, which means the device isn't performing as well as it could. And then once we came up with a new design, then we had to figure out how to get that into the manufacturing space. So if a company wasn't already set up with a distributed manufacturing system, there was no way to quickly implement that. So the challenge was not only coming up with a new design, it was coming up with a better design, a more green reusable design, and then a design that could quickly be scaled. And if we think about that long term, that type of thinking is exactly the way that companies should be launching new products and tying it into the digital value chain, is figuring out, you know, exactly how we're going to make the parts from the start and exactly what makes sense based on the number of quantities that are required and how quickly the parts need to be delivered. The second key aspect that we really looked at aside from the PPE were the ventilators. I think it's been pretty well covered in the news that both Ford and GM put a lot of energy into the ventilators, and 3D printing was actually featured in some of the press videos released around.
So sorry to interrupt. The slide is chopped off on the right. I think it's the slideshow is going on 2 screens, maybe.
I have a very wide, like ultra wide monitors, they call it. So I wonder if it's just a formatting issue between my screen and more of a standard.
I think let's just show the PowerPoint application, because then we can actually see the whole slide instead of presentation mode. Yeah, this is better. Let's just do that.
Okay.
Thanks.
And are you seeing just PowerPoint or my whole screen at the moment?
No, that's the PowerPoint.
Okay, great.
Yeah.
All right, so just PowerPoint still?
Yep,
Okay,
just the
great.
PowerPoint.
Sorry, I just want to make sure the format thing was correct. So back to where I was saying is that we were using, basically the challenge with the ventilators is that we needed more ventilators than were currently available. We needed this quickly, but the problem was that the ventilator manufacturers didn't have capacity that they could just turn online instantly. They had to acquire new tools. Those tools had to be built. Those tools had to be tested and proven out, and then they had to go into production. So there was a huge gap in terms of life-saving devices being available to the end users. And so when we took on that challenge and figuring out how to use 3D printing, and then again also thinking about this in a mindset that applies to us moving forward, is that 3D printing can enable a lot of flexibility in the supply chain. 3D printing is not necessarily the end-all be-all for any application, but almost in every single circumstance where the technology can create the end-use part, it can be used as a bridge technology when you're ramping up, or a sunset technology as you're ramping down. So the goal was to figure out which components in the ventilator could safely be 3D printed, whether it's a plastic component or using our metals technology to replace a casting, and then enable companies to do limited production as they waited for new tools to come online. So even though the capacity may have been 200 a week when the requirement was 2,000, over the course of a month, that's still 800 ventilators that could be built using 3D printing that couldn't otherwise be done if we weren't using 3D printing. because if we just waited for the new tools, we were essentially sitting on the sidelines for 4 weeks waiting for the new tools to come online. One of the challenges with that, though, is that being that ventilators are an approved FDA device, there's some challenges around getting substitute components approved, because when the initial products were made, they were not approved 2 ways. They were only approved with traditional manufacturing methods. And then there was also the supply chain concerns around, once we had parts identified that could be made additively, how do we actually identify which places to get them made and how quickly we could ramp up. So if we look at a couple of the challenges we just presented in the ventilator scenario, the trick then is figuring out what do we need to do differently moving forward, so that if this type of scenario arises again, how do we better prepare for it? Short-term, FDA actually did a really good job of fast-tracking a lot of approvals. So if any devices related to COVID were presented to the FDA, they fast-tracked those. And that enabled a lot of parts to get online more quickly than what would be typical with the FDA. But if we look at some preventative measures so that if something happens in the future, we could get online more quickly, the concept of parallel path qualification comes in. And this is actually a really key concept that we could think about with the automotive industry as well. So if you're a medical device company, each product that you release into the market needs an FDA certification to be sold. And that certification can be very time consuming and also rather expensive. But if you were to do 2 different similar devices at once, it would be significantly less expensive than doing these 2 similar devices at 2 different times. So one of the thoughts as we think about enabling extremely flexible supply chains is to do the 3D printed components at the same time that you would do the traditionally manufactured components. Then you would have 2 sources qualified. And as supply chain interruptions popped up for any reason in the future, could be even as simple as a supplier gets flooded or something like that. Maybe there's one component not done. If you had a sub-assembly pieces or an individual component qualified with 3D printing, you could then look to outsource that individual piece to a 3D printing supplier, and a service provider or manufacturing partner could then give you the 3D printed parts as a bridge. And the more and more we look to this, it's also organically going to build out this supply chain, because there also is the gap that many of the service providers today are either engaged in specific production contracts or specific prototyping activities. And the flexibility is better than it is with CNC, but it hasn't quite reached the full potential that it is, because there isn't this onesie twosie kind of production ramp up demand. And as more of those use cases come in, we believe that service providers will buy additional capacity, knowing that they'll be able to sell parts as more and more companies move to this format. So specifically, why was EOS able to help with a lot of these challenges? There's some really cool stuff coming with the earlier example I showed with the PPE around facial scanning, reusable N95 masks that are safer, lighter fitting is something we hope the medical industry can do moving forward. So very close to announcing that, and the partnership that we worked with the hospital and the software company. So that's something we can look for. But a few of the reasons EOS has been able to really help a lot with the COVID situation is that we do have 30 years of industry knowledge. EOS is one of the original pioneers of 3D printing, if you're not familiar with us, and we celebrated our 30th year in business last year, so actually 31. Between Laura and our existing dedicated medical staff as well throughout EOS, we have people in our consulting team and business development with specific medical experience. We're very good at knowing the unique requirements of the medical industry, and also have experience helping customers get parts qualified, which really makes us very agile in moments like this, because it's not our first rodeo. And then as well, EOS has more industrial grade machines in the field than anybody else. So when it does come to some of those challenges around ramping up a distributed manufacturing supply chain, we will have the most contacts, and because we have the most systems in the field, there's going to be the most capacity for a given machine model or a given material. And if we look at some of the other FDA projects that we've done, the example in the middle on the left, if you can see my cursor here, is actually done at the University of Michigan. And that is a Trachea Device. And that was done with scan to print, where we actually scanned a patient in this area. We're able to uniquely identify their individual body part and then 3D print a component that was designed to perfectly fit their body part. And those are some of the same concepts we're looking at with PPE, where we actually take a facial scan of somebody and then 3D print a reusable device uniquely designed to their facial shape. And everybody has a different size nose, cheek, mouth, etc. You know, all these shapes that come together to form your parts are different as well. And that's where we feel that scan to print around PPE could be such a key technology, because if you could minimize the gaps around the nose and the chin and on the cheeks as people talk, you're going to minimize the space, the negative space there that actually germs could fly into. So we think that's a really key technology. If we look at the ventilator example and around producing things efficiently, this bottom center example that my cursor on now is a centrifuge. And that particular component went from 32 pieces down to two 3D printed components. So that gives you a lot of flexibility in ramping up. And if you could imagine dual qualifying a traditional ventilator used with injection molding and die casting and a 3D printed ventilator, if the 3D printed ventilator, you know, had 2 components for every 30, and we look at using as 3D printing as a bridge technology, it would really, really efficiently help people get up and running when they need to kind of get this spot on demand production. And that's one of the things we need to think about too when we're doing these dual certified parts, is that the 3D printed part doesn't always need to look like the conventional part, it just needs to perform the same. And then the last example here is done by Shapeways, which is a pretty well-known service provider. They have offices in New York City and in Europe. And this is as well a scan to print orthesis device where we scan the patient's foot and then 3D print a soft elastomer-like component to build their device. So as we look at where we go from here, I think one of the toughest things to think about with COVID is that it's not actually really a unique situation. It's actually probably just the largest example and the one that affects us the most personally, relating to supply chain disruptions. But if we look at about the past 20 years, we haven't gone more than 5 to 7 years without a major disruption in the supply chain. If we go back to about 2000, there was the dot-com bubble. Then we had Katrina after that. Moving forward, is it still on PowerPoint?
Yep.
All right, thanks, sorry. We had Hurricane Katrina after that. Then we had the stock market crash in 2008. There was the Japanese tsunami shortly after that. I believe that was 2011. There was SARS in 2015, and now we have COVID. So you can see about every 5 to 7 years, there's a major disruption to the supply chain that is usually something we can't forecast, something like a stock market crash or a disease. And because the economy is so globally interconnected these days, obviously things that happen in China or in Europe and Mexico affects us in Chicago or Michigan or California, wherever you're located. So we do need to face these facts that having a dual source supply chain that is a mix of traditional manufacturing and additive manufacturing isn't really a short-term solution. It's really a requirement to ensure that your business can thrive no matter what the conditions are moving forward. So I'd like to think that companies shouldn't stop any of the initiatives that are going on right now. If people are looking at dual source or how to use 3D printing to get them by, we should continue to learn and grow with this so that we're more flexible in the future and we have the resources on hand to do it more quickly next time. And lastly, we have this concept called the digital value chain, which if you Google EOS 3D printing and digital value chain, it should pop right up. But a lot of the concepts we've talked about today, we feel are how many parts moving forward should be done. So if we tie this back to the automotive industry and we look at crash testing as being the biggest certification to getting a vehicle on the market, there's a lot of components that you could probably qualify a vehicle with 3D printing, knowing that the injection molding or die cast component would perform similarly or better. So if we qualified a lot more vehicles with 3D printing and we knew that a 3D printed dashboard or door handle or bracket was safe to use for crash testing, you could actually slowly ramp up your vehicle production with 3D printing, then switch to traditional manufacturing during the main vehicle life cycle. And then as we discontinue that vehicle and it becomes truly a part situation as we sunset it, because initially when the vehicle was qualified, we did the 3D printing testing, you could then switch your spare parts business to 3D printing and start to only build the parts when they break and not have to inventory them. It's a really famous case study with EOS and Daimler that we did in Germany where they are 3D printing bus components when they break. And it makes a ton of sense, but one of the biggest challenges for them was because they were doing vehicles from the late 80s and early 90s, was that they had to stop and re-qualify a whole subset of components with 3D printing, versus if we look at doing this for the future and you qualify things up front, it'll save a lot of time and money moving forward towards the end.
Thank you. John, EOS sells machines, or do you also sell service to produce parts? Do you have your own 3D printing facility?
Yeah, so traditionally EOS does not sell parts. There are some stuff with COVID where we've broken a lot of our rules for essentially what we will and won't do to support customers because people needed parts and we may have had a machine available or a material available with our internal fleet of systems. So we did jump online with production. But generally speaking, our goal is to help people identify applications. And we have a lot of engineering that we can do as a service where we can help people design parts. If you had an FDA part as an example, we actually have a service to help you get your part FDA qualified, but we wouldn't actually act as the manufacturing partner. We would sell the engineering services, the machines themselves, and then the materials once it was actually up and running.
Okay, thank you. And I would like to remind the audience that please have your questions coming. We already have a couple of them. You can type them in the chat box, or there's a Q&A box. Also, you can raise your hand, and so that I can unmute you and you'll be able to speak. So our next panelist is Dan from Formlabs, and Dan, I'm going to make you the presenter now. Here you go.
All right, thank you very much, Shashank. Can everyone see my window clearly? Is that working?
Yep.
Perfect. Thanks also to the Johns for great presentations before mine. I represent Formlabs, and I'd love to talk to you about how our response to COVID-19 played out and how I think there's some really clear lessons for the automotive industry from that. And I'll cover 3 topics. I'll introduce us as a company, I'll go through our response to COVID-19, and then I'll try to distill some lessons for the automotive industry from that. The key thing to understand about Formlabs is our mission. We're a company about expanding access to digital fabrication so anyone can make anything. And practically, that can mean a lot of different things. It can mean an individual engineer and designer can do their prototyping, but it can also mean that a factory can switch over to additive manufacturing, or that a dentist can make dentures using our printers, or a hospital can make medical devices. What we're really trying to do is push the boundaries of what's possible with additive manufacturing in every way that we can. We were founded in 2011, 2012, actually out of the MIT Media Lab, and we started with a Kickstarter for the Form 1, which was the first desktop stereolithography 3D printer. So stereolithography is a process where a liquid resin is solidified in response to a beam of light. That's how the 3D printed part is made. We've progressed from the Form 1 to our current generation, the Form 3 and 3L, which are our engineering printers, and the Form 3B, which is our dedicated medical and dental printer. And we've really had a huge impact in terms of the number of printers in the field. We have 60,000 printers out at customers, and our customers have used those printers to print more than 50 million parts. And so as we've grown from 2012, from being a 5-person company to now a more than 500-person company with more than 100 million in revenue, we've really seen that the scope of what's possible with additive manufacturing has grown and grown and grown, and we've been excited to be pushing that forward. Our vision has really crystallized around the idea of an agile future for digital manufacturing. And what I mean specifically by that is that our machines, which are desktop sized, but as capable as large-scale industrial machines, let you do things with additive manufacturing that weren't possible even with previous generations of 3D printers. Specifically, it's just like the transition from mainframes to blade servers for folks in IT. The idea of one big unit being replaced by many identical mass-produced units. You get a lot of benefits from that. You get benefits in redundancy, you get benefits in scalability, you become more flexible. It's possible to have leaner processes and facilities. And these mass-produced units, because of their smaller form factor, if they're designed well, can be much easier and more convenient to use. And rather than just talk through this now, I'd like to show how this played out with our own response to COVID. A little context, we operate a facility in Ohio that really has two purposes. One, it's our chemical plant where we make all of our resin materials, but it's also the place where we produce the free samples that customers or potential customers can request on our website. And in a typical week, including in March, this facility was producing 5,000 samples per week. And that was using 250 printers and had 11 full-time employees. And to give you an idea of what I mean, here's a snapshot of our website. You can go to formlabs.com and request a sample, and you get to pick which of our materials you'd like and which sample part you would like, and we'll mail it to you for free. And all those samples are produced at our Ohio facility. We were in a unique position as the COVID-19 crisis began to unfold because we are already a medical device company. I mentioned that we had a dedicated medical and dental printer, the Form 3B, B is for biocompatible. And our Ohio facility, I also said, is where we produce all of our resin materials. Well, some of those resin materials were already specifically for medical devices and had indications that were registered with the FDA. As a result, we were able to transform relatively quickly from a sample making facility to a facility that was producing medical devices. It helped also that we already had ISO 13485 certification. So for you automotive folks who might not be familiar with that one, it's the same as ISO 9001. It's a quality management system, but it's specifically for medical device production. So within a 2-week changeover, we were able to go from producing these sample parts to producing test swabs for COVID-19 testing. This was a really, really crucial shortage in the early days of the pandemic, and it actually is still continuing today, especially in certain regions. And what was great about our position is that because, as I said, we're a medical device producer, we could reach beyond just the personal protective equipment applications and make a medical device that was in short supply. And the amazing thing about additive manufacturing is it did allow us to do this changeover from 5,000 samples per week to up to 100,000 test swabs per day with a very, very short shift period. The way that this was possible is we partnered with 2 medical institutions, Northwell Health, which is one of the largest health systems in New York, and the University of South Florida. These are organizations who we'd worked with for a number of years before. They actually designed 3D printable swabs for performing COVID-19 testing, and we rapidly iterated with them so that they could refine their swab designs and then perform clinical trials. The results of those clinical trials was that the 3D printed swabs performed as well as standard swabs. And so we've since actually gone into production and have been supplying these swabs to hospitals and other health facilities throughout the country. What's even more amazing is that once we had this workflow validated, many of our customers wanted to get on board. And I do want to say specifically that we restricted swab production to customers who were either qualified medical device producers or hospitals or other facilities that were able to produce to the required quality standards. As the earlier presenters were saying, you really don't want something unsafe on the market which means even if the design is safe, you want a qualified producer with the right quality system in place so that they can make a medical device that actually works. The result of this is that our customers' capacity now exceeds ours for swab production, and it's distributed all over the world. I think we're quickly approaching 10 countries where we will have customers who are preparing to print swabs or are already printing swabs. Also of note is the fact that because our printers are a small form factor but can scale to large facilities, we have been shipping and installing printers throughout this crisis because it does not need an on-site technician to get our printer set up. This means that in several cases, factories have sprung up from nothing to full production using our printers over the course of the crisis. And when the crisis is over, they can be repurposed to making products that have more lasting need than the medical supplies that are required right now. Part of that flexibility is even during the crisis, if something else is necessary, we can quickly adapt our production. So John from EOS mentioned that ventilators are in short supply. One thing you can do, it turns out, is to adapt a Bipap machine. So this is a bi-level positive air pressure machine. It's a sophisticated version of the continuous positive air pressure machine folks with sleep apnea might use at home. Formlabs actually got the very first emergency use authorization from the FDA ever granted to a 3D printer company for the production of a Bipap adapter designed by Northwell Health. These are something that we can produce now. We haven't seen a ton of demand at the moment because thankfully there has not been a ventilator shortage as folks have feared. But the amazing thing about additive manufacturing, especially when it can make medical devices, is that you can very quickly switch what you need to make based on what society is demanding. In addition to our medical device efforts, we've also created a COVID community library. This you can think of as related to the NIH part library, but specifically geared towards Formlabs printers. And the reason for this is because we knew we had so many printers in the field and so many owners of our printers volunteering to do something. We wanted those people who were not medical device producers to be able to make something useful with as little overhead as possible. So as I mentioned, we put out a call for volunteers. We had over 3,000 people and organizations volunteer to use their Formlabs 3D printers to help out in this crisis. And we produced a curated part library in partnership with Bellis 3D, which is a scanning company, the Yale School of Medicine, Materialize, and other members of our community, posted it on our website. And for any of these parts, someone with a Formlabs printer, all they will have to do is download the file from our website, and it immediately goes to the printer. So there's no post-processing of the file needed. There's no setup needed. It's fully set up to print on a Formlabs printer. So you can think of it as one stage of additional processing from the NIH website. And we have also been working on contributing various parts and design improvements to the NIH website, and have also been working with America Makes through this process. Another aspect of the crisis is maintaining business continuity. So it's not enough just to be dealing with the short-term shortages of medical supplies and PPE. You also have to think about how your organization is going to be maintaining its core mission during this crisis. And one of the things we found is that we've actually been able to break up large installations of printers that we had at our headquarters, which is currently largely closed except for those folks doing critical medical work. We've been able to break up those large installations and distribute printers to people's homes. And we've seen no loss of productivity in our technical work, our design and our engineering, because people are prototyping in their home offices and are actually communicating with physical parts by sending digital files to each other to be printed in multiple locations. And that includes communicating with our suppliers overseas. We've seen that this is really, for us, bringing home one of the key digital futures of additive manufacturing of you can take the production facility and replicate it in a single printer installation as well. So you can know that the factory will perform correctly because you've tested it on a single printer. And you can have excellent engineering communication by printing the same part in multiple locations. Now, after the crisis, we'll have a choice to make about whether we want to assemble these large print stations in our headquarters or leave the printers distributed with our workforce for their home offices. And I think the optimum is going to be somewhere in between. So if I step back and ask, what can I learn as someone who's spent a number of years of my career in the automotive industry? What would I go back and tell to my industry colleagues? The first thing I'd say is industrially capable mass-produced 3D printers are really a major breakthrough for the future of not just manufacturing in general, but additive manufacturing has really taken a step forward with printers like the ones that Formlabs makes. Because the facility is made up of many printers as opposed to one single expensive printer, you get a ton of redundancy. So you can have a manufacturing facility like our swab facility with effectively 100% uptime, because anytime an individual printer fails, it's very easy to swap in another mass-produced unit. Scalability is also a consequence of this. As the demand for swabs has fluctuated, we've added and removed printers from our production facility really quickly and easily. Flexibility is also a big deal. This is really common to a lot of additive manufacturing solutions. As the situation has been evolving, we've been updating designs and even changing what products we're producing. So we can shift seamlessly between swabs and those Bipap adapters, for example, just based on the needs of the medical community. Lean enablement is also an area that I really want to highlight. I mentioned that we have customers in a number of countries who are producing swabs. Typically, those customers are very close to demand. So instead of us trying to understand what demand in many places is like, the folks with the demand are printing the swabs that they need on time, the exact quantities that are required. So there's almost no waste in this process, compared to the typical high degrees of waste that might occur in crisis manufacturing for uncertain demand. The last thing I'd mention is the ease and convenience, where not only have we at Formlabs been able to send printers home with our employees, but many of our customers have done the same thing. We've also been able to deliver printers to hospitals throughout this crisis, which are then immediately used to make medical devices, including those swabs. We've been able to have new factories set up by customers who've decided that they need to manufacture certain things. We were just shipping them our printers and having video calls with them to get things going. And it's really proved, I think, conclusively that you can go from nothing to a global digital factory in weeks, which is a case that I think additive manufacturing companies had been making with words for a very long time. And I can now look back on the past 4 to 6 weeks and say, this is now something that we can point to and prove once and for all is possible, which is a lesson I would really want to bring to the automotive industry. If you use additive manufacturing correctly, it is possible to be so much faster and more adaptable than you can be using standard manufacturing techniques alone. It's also worth remembering that additive manufacturing is not magic. It doesn't produce everything. It's a supplement to traditional production techniques. So we, for example, are excited for the day when we no longer have to make swabs because standard swab suppliers are producing them in staggering quantities at ridiculously low costs. Like, we're excited to get out of the swab business, but while we're needed, we can be doing that. And so I imagine the equivalent for the automotive industry is not just to deal with supply chain disruptions, although that's very important, but also to explore a diversity of parts at the beginning of a product design process, to do more customer testing, to do broader and more thorough safety testing. There's really an opportunity for more iteration, more variation, more responsiveness by using these modular additive manufacturing solutions.
Okay. Thank you, Dan, and thank you, everybody. Just want to remind the audience again that please have your questions coming. And we already have quite a few. We got 20 minutes on the clock, so let's keep going. So one common question that has come up is material standardization, and that's a question that almost in every additive manufacturing webinar or meeting I go to is raised. So first, I want to ask John from America Mix, what is your organization doing to bring people together to talk about issues around standardization, especially when it comes to materials?
Yeah, so it is, one of two or three hottest topics in every additive event, I think, or any discussion. So, so we're focused on, again, getting things to the point, ideally, that they become standardized or specs can be built around them, like we are used to seeing in more traditional manufacturing settings. So that we've been engaged in driving a number of conversations for the last couple of years around, how do we actually take the next step instead of talking about it? And we still are talking about it. There is some work going on right now that we've been involved with NIST on a common data schema, or more of a data dictionary of what are the elements that need to be considered as we are developing materials. We're very interested in coming up with we would love to get focused around the top 5 materials that need developed. So, we've done a lot of work in the aerospace and defense community. We've seen a lot of interest in the automotive community here as of really the last year. Materials are centric to all of those conversations. So we've had some really good examples of how we've, engaged in some allowable studies and things like that have ultimately resulted in SAE specifications and things like that. There's 2 different products that have come out of funded studies that we've done that have, I'll say they're in process right now. There's a Type 64 e-beam program that SAE is, we've granted access to that data, and they're working on building a spec around it. Having a lot of, we're having discussions, I wouldn't say a lot, with the MMPDS, folks on what book 2 looks like. So what are the AM specific materials? Again, this is primarily around the metal side of things. We've through FAA have proved, and it's one of the case studies that were included in those backup slides that I'd provided, that is on an Ultim 9085, where we actually went through and with a particular manufacturer went through a qualification process and equivalency program with NIAR and FAA, that you can now buy an upgrade to a system. You can buy vetted material that you can ultimately produce components. I think we have visions that we've got to get well past that, so it's not just buy this one material from this one manufacturer and follow this exact parameter set. That is a step, but it's not, it's not the long-term solution. So we're in, there's some discussions going on this summer. There's an event that we're teaming up with NCMS on, if that's a familiar group to you, anyone on the phone, National Center for Manufacturing Sciences. We've worked together with them for the past 4, I think this is the 5th year of a business model AM workshop event that we've hosted at Lockheed. We're doing that virtually this year. One of the sub tracks is on materials. And I hope to be letting everyone know we're going to be, announcing something soon in that space around a metal alloys qualification program at some level. So hopefully you'll hear about that soon, but we're very interested for sure. And really from our point of view, it's about coming together around, to get it done in a way that we can standardize and move forward.
So from machine suppliers perspective, is there appetite to look forward to material standardization? I know like that's one of the probably a revenue stream for you guys.
I mean, I can say from the EOS side, it's an interesting topic. I mean, one of the challenges, if you compare it to, like, say, my background in CNC, or if you even compare it to injection molding, but you know, you're not forming, like in any other discipline, you're not actually forming the raw material in the part at the same time, and you are with additive. So it's a really big challenge. Like, it would be wonderful to get to, you know, an SAE aluminum standard that everybody could comply with. And obviously, I think there could be like a minimum threshold that ourselves and our competitors could hit. But the reality is that each one is going to be different, and you probably have to qualify, you know, each individual machine supplier's material, because the way that laser interacts with the powder, because everybody's using different laser settings, and then the motion control of the lasers are all different, you're going to get slightly different end results. So that's where the additive industry gets really complicated. You kind of mentioned the business model standpoint. You know, we're one of the few companies that produces both metal and polymer systems. Both of our technologies are what we call powder beds. So you load a system full of powdered material, and then you use a laser to fuse it together. The polymers business is much more materials a revenue stream. The plastic machines consume a lot more metal, and there's also a lot more plastic. And there's also a lot more development that goes into the plastic materials. Metals is a little bit more forgiving. So if you look at EOS, you know, I would say probably 90+% of our customers on the plastic side do use our materials. On the metal side, it's probably 60%. And that's because there's a lot of commodity-based materials that, you know, large organizations that are going to go into production and have the resources will do their own R&D. So we look forward to the opportunity. You know, we do understand why it makes sense, but it is a little tough because you are trying to force additive manufacturing, you know, into a you know, CNC or a die cast kind of framework, and you need to think differently when you do additive.
Mm-hmm. Okay. One other question. Two people asked it. So after COVID, there's a push to bring manufacturing back into the US. What role can additive manufacturing play in being a catalyst and bring value to produce parts in the United States?
I mean, no, I just talked, but I actually love to kind of jump on that one too as well. I think that's a really good question, but I think one of the things we need to realize is that additive actually has been probably the greatest organic reshoring tool for the manufacturing industry. If you look at CNC equipment, there's like this crazy stat you won't believe, but it's something to the effect of 50% of the world's CNC machines go to China. So it's a milling machine, an EDM, a turning center, whatever. 50% of them coming off anybody's production lines, whether they're made in the US, made in Japan, made in Europe, made in China, go to China. But if you look at additive equipment, the US is the largest market for industrial grade 3D printing. So we already are the leaders in this manufacturing. And then if you look at the industries that 3D printing is currently serving most heavily right now, they are the industries that have already best survived a lot of the outsourcing crisis, you know, from 15, 20 years ago and into today. And that is the aerospace industry, which is obviously going to be challenging coming out of COVID. It's the medical industry, which we've talked about today, and then the automotive industry, which isn't fully with additive in production yet on a wide scale, but it's coming on strong, which is obviously why we're talking today. So it's really something that's just going to happen. I think what the difference is going to be is that when people look for opportunities to reshore that aren't doing it already, I think they're going to naturally find that 3D printing is the easiest tool to do that. And I think that's where the two things go hand in hand together.
Right. Anybody else?
Yeah, I'd love to jump on that for a second. One of the challenges you face when you're reshoring a factory is making sure you get the return on investment for your capital, that you're making a prediction about what the economic future is going to be like for the whole life of all the machinery that you buy. And one of the great things about reshoring with additive is that you have a huge amount of flexibility so that if market conditions change, you can change what you're producing. And I think that really is going to be the catalyst for a new generation of reshoring, because factories with more digital intelligence, more additive machines, more automation can potentially be much more flexible than traditional factories, and so can capture a return on investment even in uncertain market conditions.
A couple of questions are there on metal powder. One of them, metal powder cost also represents another area of opportunity to increase competitiveness of 3D printing. Do you see promising areas of research to change the way powder is currently produced for low cost, basically?
John, I don't know if you, from kind of an industry more neutral standpoint, have an answer. I mean, I have one as well. I just don't want to kind of hog all the questions or have it be
the quick our 2 cents. I think yes, we're certainly seeing opportunity. We're not seeing opportunity there. We're seeing research being done there. There are some, there are new or emerging atomization in different processes that are coming on that have proved at some level to be promising. There's some work going on in the national labs that appears to be promising. Still a little bit away. I'm sure John has some more direct answer on what they're seeing. I mean, I will say, in whether it's our conversations with automotive or even some of the, we do a lot of work with the Department of Defense for ground vehicles and things like that. Material cost is a big deal. So there's a lot of interest in, alloys that are traditionally much lower cost. So, I imagine that's part of where the question's coming from. But John, do you have a more direct answer?
Yeah, we do have one. So to back up a step on metal powders, if you're not familiar, basically every powder that exists today for powder bed technology is almost exclusively designed and produced for 3D printing, and it's a gas atomization process. So that's one of the key reasons that the powder is so specific and so expensive. But we recognize that gap too. And you also need to understand the history of these technologies came out of prototyping. And one of the fears that we had, going back 25 years ago when metal 3D printing was new, is that we needed to ensure that customers weren't worried about the metallurgy and they were worried about the finished parts. So for a long time, things were closed off. We kind of took the onus to make good metallurgy. And so we had these powders that were perfectly designed for 3D printing. And they gave you these very high produced finished part qualities, which is also one of the main reasons that, like aerospace, an example, aside from weight savings and lower volumes, could jump into additive so quickly, is because our material properties most closely match aerospace. If you look at the automotive industry, when we tried to make like an aerospace grade forged, aluminum part, all we're doing is slowing down the build process and increasing the stock of the feed powder. So one of the things we've done is looked at water atomized powder, and we do have one of those on the market where we take a traditional metal powder that would be used in a press and sinter application and use it in our 3D printer. And so the feedstock powder is less expensive. You're going from roughly $110, $120 a kilogram for the gas atomized to $55, $60 a kilogram for the water atomized. And the other beauty of this is that it builds 2.5 times faster. So of course you're wondering, well, why aren't we doing this with all of our powders? Right. One of the challenges is that when the powder shape isn't a perfect sphere, which is what you get with gas atomization, you do see a little bit of a change in your finished part quality. So instead of getting to like 99.9 or 100% dense, you're going to get somewhere around 96. But if we take a step back and think about the casting industry, that's a perfect replacement for the casting industry. So we should see more of this stuff coming forward. One of the other things too is if you're new to additive and looking at additive, you couldn't strictly look at your existing part today and say, okay, I pay $20 a kilogram equivalent for tool steel and my part is this big. So additively, if I'm paying $100 a kilogram, it's going to weigh this much and cost this much. It's not apples to apples that way. To do additive effectively, you should be redesigning your parts. If you're redesigning your parts effectively to take advantage of additive, your parts should weigh less. So therefore, you're going to use less material. And then also, if you look at producing it with like a milling machine or with additive, there's different costs that come out. For die cast, traditionally, you're not ever making a tool. If this were a machine billet part, you're not going to have a bunch of chips in the hopper at the end of the day that need to then be cleaned and recycled. So you can't do just a one-to-one cost based on math. We have something that we're within 10x of an initial time study, it probably makes a lot of sense to look at doing it additively. But if we're outside of that range, that's when you could probably look at the cost as a first checkpoint and say it might not work.
Okay, so we have a couple of minutes left on the clock. So just one last question, and I think it's a good one. Where do you see additive manufacturing in the next 5 to 10 years? And I will let all of you comment and have your closing thoughts as well. John, you want to start? America Makes?
Oh, sure. Yeah, I think in the next 5 years, we're going to have much more access to materials data for design, which is going to ultimately lead to our ability to more rapidly qualify components. It is where the vast majority of our energy is right now. I know a tremendous amount of the research that's going on today relative to qualification and certification of components is focused on that. Materials obviously plays a vital role to that, and we're going to make progress in the next 5 years. I'm positive of that. I think the other major trend that we're going to see, and I would say, it's being highlighted, and what brought us all together today, maybe around a COVID response, is highlighted the technology quite a bit. And although this is not new to any of us on the phone, it may be new to some of the folks that are dialed in and may not have great exposure to what additive is. And it is no panacea. It is not going to solve all the world's problems, and we're not going to start printing automobiles in the next 5 years. However, as technology is rapidly advancing, costs are coming down, our ability to retool rapidly and spread out and diversify that supply chain, I think we're going to see continued accelerated growth from a supply chain adoption of the technology. And then just like we saw, John just kind of talked through an aerospace example and some of the reasons why it's been adopted by that industry, we're starting to see automotive become much more interested. We know of, some of the use cases that are out there. Many of them don't get talked about, but we know there are a number of cases that are being realized today or closer to the point of being realized. And I think it was Dan, and I'll then let them talk through this example of where does additive fit in, and whether it's traditional rapid prototyping, like it's been extremely effective at over the last few decades, to this, an idea of bridge manufacturing and being able to quickly retool and get, potentially turn vehicles, every couple of years versus every 5 years, and these, monumental tasks of retooling a line. Some of that's going to start dialing back, and we're going to be able to reface things a lot more quickly, and therefore provide consumers, new looks much more rapidly than we can do with conventional tooling. So I think the merging of conventional and additive, and we'll stop just saying it's another tool. We all know that it is. It's just going to be another tool, and we're going to start actually using it that way.
Right. Thanks, John. Dan?
Yeah, I think one of the key things that's going to transform additive in the next 5 to 10 years is also something that the other John alluded to, which is design for additive. I've really seen a huge leap forward in design tools specifically geared towards additive manufacturing, even in the past year or two. And I think as those tools begin to propagate out into the market a bit more, the business case for additive parts is just going to get better and better. And so we've seen recently at Formlabs huge adoption of our soft materials. So we've produced a number of elastomeric materials that are 3D printable, that then when they're combined with sophisticated design software that can do things like easily produce lattice designs and allow for easy customization to individual users, individual consumers, really let you do things that weren't possible even 6 to 12 months ago. So just one example is we do a pair of shoes with New Balance now with a 3D printed midsole that has special shock absorbing properties. And that product would just not be possible without sophisticated design for additive. And I think really, if I'm looking forward 5 to 10 years, you're going to see more and more products by big manufacturers that would have been impossible without additive manufacturing. It's one thing to say we're going to get a lot of process efficiencies out of it, and that's where a lot of the talk today has been. But the other piece is that we're going to see a lot more customer value generated by additive that isn't possible with other technologies.
Okay, John, very quick.
Great, thanks. Yeah, I've got a similar answer to Dan, but a little bit different flavor. You know, as example, EOS did a shoe with Under Armour as well. And I think as more and more products like that come to market and the greater awareness of what 3D printing is, and it's not something to like buy a cool coffee cup on Etsy is, I think that's really one of the things that needs to happen to create awareness. And as we see it in more and more consumer products, and it gets in more products that we touch every day, the awareness is going to become more available. And then as new technologies and new materials come online, you know, like the example of that 316L, last year we didn't have a material at that price or that speed. This year we do. So as we get the technology into more and more people's hands, and then we have faster and lower cost solutions, it's just going to multiply quicker and quicker. And I think the automotive industry, from a kind of a traditional B2B model, is going to do a lot more, I think, for 3D printing than aerospace or medical does, because I think we all touch our cars daily. And as we become aware of 3D printed components in the cars, I think that's going to help tremendously as well, the same as sneakers and football helmets and other components like that that we start to see in the news.
Okay, thank you so much, all of you, for your time today. And it's been an excellent presentation and webinar. And to all the attendees online, thank you so much for dialing in. This presentation will be available on our website. You will also get an email with the link. And if you have any additional questions, please email me, and we will see if we can get an email reply from our speakers. So again, thank you so much, and have a great day, everybody.
Great. Thanks for having me.
Thanks for having us. Thanks.
Thank you.